Hello, this is a brief video discussing the architectural and physics-related aspects of diagrids.
This is an example of a Diagrid building. We just wanted to demonstrate the simple idea of Diagrid structure. We were inspired to create this model based on the Hearst Tower in New York, designed by Norman Foster. There are many buildings that are used a similar Diagrid structure. For example, Swiss Re in London, the Bow in Calgary, Seattle Central Library in Seattle by Cole House, and the newly proposed One World Trade Center in New York by David Charles. Columns are used in normal structure in order to keep the building stable. However, when a Diagrid structure is utilized, there are fewer or no columns because the support core is in the middle of the building. The core, beams, and the Diagrid structure are connected and held together. When we researched about material consumption in constructing buildings, we discovered that the Diagrid system uses 20% less steel than normal structure. Since they are using less material, it is promoting sustainability.
Everybody, I'm going to talk about more detail on Diagrid structure. Diagrid structure is extraordinary structure that makes building more aesthetically and efficiently. This structure is such an innovative way in architecture industry. Today, the building like Swiss Re Tower and Hearst Tower in New York are most well known as Diagrid structure system affected in architecture. Diagrid structure have great opportunity to reduce building cost, building material consumption, and reduce building construction period. And also, it's easy to fabricate. Originally, Diagrid is not a new technology. It was used in an old airplane structure. It was constructed to have less impact on air resistance.
Hello, we are going to talk about the most important part of the Diagrid system,
The node.
In Latin, the word node stands for a node.
Nodes are redistribution or communication points, essentially a place where things meet.
In architecture, nodes are the place where all the beams meet.
And where all the forces are redistributed.
Usually, nodes are prefabricated and brought to the construction site.
Yes. Nodes have two aspects, the architectural aspect
and the structural aspect.
Architecturally, the node must be smaller than the rest of the Diagrid elements in order to maintain that crisp, clean look. However, since we are in physics, we will only be going in depth into the structural aspect.
As we mentioned before, nodes are where all the forces are redistributed. And there are many forces acting on the buildings, so nodes have a lot of work to do.
For example, there are gravitational forces, dynamic loads, which are sudden gusts of wind or an earthquake, dead loads, which are the weight of the walls, the floors, the roofs, and any permanent surface equipment.
And there are live loads, which are weight of the people, furniture, or that is movable. And roof live loads, which is snow, rain, etc.
So basically, these nodes are responsible for redistributing a lot of forces.
Nodes redistribute these forces in two ways, in the 2D plane and in the 3D plane. Interior nodes, the ones on the sides of the building, distribute it in the 2D plane, meaning the forces are spread out vertically and horizontally.
And the corner nodes are responsible in 3D space, meaning forces are distributed to all possible directions. Therefore, corner nodes are a lot more complicated. Vertical loads are transferred to the nodes and distributed as horizontal shear. Shear is the force applied parallel or tangential to a surface as opposed to perpendicularly.
Yes, and all these loads and the nodes are responsible for are transferred to the perimeter. That is why building which utilizes the Diagrid structure usually has an absence of support columns.
The main idea of this model is to show how Diagrid structures distribute and transfer gravity loads. So in other words, we wanted to demonstrate the force distribution As water runs down the straws, it is diverged into two of its lower straws, which are 60 degrees apart, and a tree-like repetition continues. The reason why the straws are 60 degrees apart is because equilateral triangles distribute forces equally. The central two containers should have more amount of water than the external containers because this concept is similar to the Fibonacci sequence.
If we continue this model horizontally and connect its starting and end points together, the structure becomes a diagrid. The only difference is Diagrids horizontal beams, which are not shown in this model.